Welcome everyone to our meetup, and this meetup focus on the MVVM architecture pattern or design pattern. Well, there is some confusion about whether it is an architecture pattern or a design pattern. And if you check the web, you can find voices in both options. I will just put a link in the chat so you can read it afterward. One thing for sure, MVVM is a pattern. It is a pattern coming from Microsoft. And as a pattern that comes from Microsoft, you will find this pattern when using Microsoft frameworks. The first time I become familiar with MVVM was, I think, 15 years ago when I did some WPF applications. Yeah, 15 years ago, 16 years ago. And after a while, I found that pattern relevant not only for .NET application, but also for application developing other programming languages. So in this meetup, my plan is to implement the MVVM pattern in a Java application, Java native application for the desktop. This is my plan. And I have 30 minutes. Actually, I have 28 minutes. Okay, so let's start. So let me start the IntelliJ. From time to time, I will use my iPad to explain what I'm doing. I will close this project and start a new project. And the new project, it will be a Java project. And where should I put it? I mm, I will put it here in documents, and the name of the project would be MVVM demo. Okay, that's it. I'm using Java, and this is the project I've just created. I'm using IntelliJ. So first, let's create a package. And if you take a look at the diagram, then you can see that we have the view, we have the model, and you can guess that the view component is responsible for what we see for the user interface. The model component is responsible for holding the data. Holding the data might be holding the data in a database, in files. It can be many possibilities. It can even be handling the data coming from other computers by using web services. But these are the two components that I guess you already understand, you already guess their purpose. The view component is responsible for the UI. The UI we see, the model is responsible for the data, holding the data, managing the data, and get us with the data we need, and so on. So let's start working on a very simple application. It should be an application that allows us to do two things. One is to save text as a memo in a file, and the other reading from a file. These are the two operations that the application should allow us. And as in any other project, my recommendation is to start with those parts that the other parts depend on. So in this case, let's start with the model because the view depends on the model, and the view model, the component in between, is also, it depends on the model. So let's start with the model. And as my recommendation to every developer, start with defining the interfaces. So I will try to keep it clear by calling the interfaces with names that start with I. This is something that comes from .NET. In .NET, developers usually add the I for make it clear that this is the name of an interface. So we have I model, the interface, and we have the model. Now let's start with defining the methods in our interface. So basically what I want to allow in this application is two operations, two functions. One, saving data to a file, the other, reading data from a file. So let's call those methods public void save data, and this method will take the name of a file and the content we want to save to that file. And the other method will be load data, and it will take just the name of the file, and it should return the data itself, the string. Now, working with files or database or whatever, usually we should think about exceptions that might happen. And my recommendation, whenever you develop a project, a library, define your specific exception classes and make them checked exception, meaning make sure the exception class you define extend exception. So let's define model exception, and I will specify that it extends exception. And then the minimum is having some constructors to allow us creating a new exception object with a specific message and a throwable. So if there is an IO exception thrown, we want a model exception to replace it, and we want to pass over to the constructor of model exception the code, the reference for the original exception, the IO exception that happened. Now let's add to the signature of each method throws model exception. Why? Because we want that from now on, it would be clear that when calling each one of these two methods, a model exception might be thrown. So this is the exception that must be handled, not IO exception, not anything specific for a database, not SQL exception, model exception. This way, if we choose in the future to replace the model with another model, we will stay with a model exception. We will stay with the same code. What do I mean? I mean that when having code that calls these two methods, now we need to place that code within a try and catch for handling model exception, or adding on top to the method declaration throws model exception. Now, if in the future we will choose to implement iModel in a different way, we will choose to implement iModel with code that works with database, the exception that will be thrown in case of malfunction will still be a model exception, not SQL exception. And if we choose to change to another model that works with MongoDB, so we define a class, let's call it model MongoDB, that implements the iModel. If something happens, we won't get a MongoDB exception, we will get a model exception. That allows us to stay with the same code that calls these two methods. We won't need to introduce any changes in those code snippets that invoke these two methods. Okay, so now when we have the iModel, let's implement it. So save data. It should work with file input stream, file output stream. Let's import java.io. So we could easily have file output stream and data output stream to put on top. And now we can have small try and catch. And if something happens, then we will throw a new exception, model exception, a problem reading data, and we will pass over the cause, the exception that was thrown. And here we can do the following, FOS, assign it with file output stream. This is correct. DOS, yeah, and write UTF, correct. I'm using the newest version of IntelliJ, so I have AI-based code completion, and based on my experience, it works fantastic. And of course, we need finally, and if over here we need if FOS is not null, then FOS close, and let's put it in small try and catch, and we won't throw anything. We can just print stack trace. And actually, we could just handle the DOS, because DOS, when calling close on it, it indirectly calls the close method on the FOS, on the file output stream that comes next. So that would be sufficient for us. Now let's implement load data. So it is very similar. We need file input stream, we need data input stream, and then we need try and catch and FS. Let's assign it with new file input stream, and let's send file. What happens here? Exception is on top of file not found exception, so that would be better. And yeah, this is fine. And DIS, and that's it. Okay, and finally, okay, so we have a model. We can check it separately, but we don't have time. But we know that we can invoke those methods, save data or load data, and we can expect something to happen. Okay, so let's try to organize all files in sub packages so we can create a view, and we can create the view model, even though there is going to be only one class there probably, and we can add the model. So let's take these classes and put it here in model. Okay, now let's move to the next to the view. Why the view? Because this is the simpler part for me to explain. View model is the more difficult part to explain. So over here, we just want a simple UI, and we will have a constructor where something happens. And we also want let's separate to creating the object and then calling start. Start will do a bit more, few more things. Now, which is going to be a very simple UI. So we are going to have a JFrame. We will need classes from Java Swing. So I do this import. And I want a very simple UI. So what I plan is having panel, not panel, I will have text field on the bottom, the south. I will call it messages, TF, for showing messages. And I want to have, I will have a panel on in the center, split to two panels. Oh, we have just 15 minutes. Okay. Panel center, and then I'm going to have panel left and panel right. And then on panel right, I'm going to have a button for saving. And on panel left, I'm going to have not a button, a text field for specifying file name. Save, okay. And on the right, I will have a button, load BT for loading data, and I will have a text field for specifying the file for which I want to load, and I will have a text field for showing the content I load from that file. So this is what we are going to have. And I just want to create the object. So frame assign with new JFrame, messages, TF, new JText field. Now the panels, we have panel center, great. We have panel left, we have panel right. And I want to add those two panels on the panel center and the panel center. Okay, let's let's here in start, I will set layout manager. Well, the default is border layout, so let's stick with border layout. Let's just specify that we want add panel center, but we want to specify where we want to add it. I think we have something like that. I think border layout. Okay, it doesn't recognize border layout. We need to import. Okay, great. So add the panel center on the center, and then I want to add the text field, the messages text field to the south, and then I want to add to the panel center. Well, first I want to place a layout, new layout manager. It will be a new grid layout. 2 rows, 2 calls, 1 row. So now I can add to panel center the panel left and panel right. And now let's add the components to the panel left and panel right. So to panel left, I will add the layout manager. The default one is flow layout, so I can just add the button for saving. So this is a save BT. We still didn't create it. Okay, and I also want to add the text field where the file name will be placed, file name TF. Okay, now that will save. Now let's deal with the other panel, panel right. So panel right, I want to add the load button, and then I want to add the file path TF, what I want, where I want to, from where I want to load. And you know what? Let's we have a text field on the bottom for showing the content, so we don't need this one, but we do need to create the other stuff. So we have a button, save, and then we have a text field, and we have the load button, and we have the file path. Okay. Okay, so we just need to set size, something like that, and then frame set visible. Now, this should work, I believe. We can just create a small program over here or we can add over here the method main. So we can just use swing utilities and ask to execute on the UI thread the creation of the simple UI and calling start. For now, this is what we're going to have. And okay, that's it. And yeah, that should work, but we still haven't handled the events. So we are short in time, so let's focus on the buttons. So you can imagine that maybe we can avoid the component in between. We can have just a view component and a model component so that the view will work directly with the model. But then there are many problems, especially problems related to the threads. We have, well, when you have UI, you have a separated thread that handle the UI. When working with files and database, you want to work with that in a separate thread. So you don't want to use the same thread you use that is being used for rendering the UI for interacting with the database or interacting with the files or in general interacting with the model. So the view model will solve this problem. The view model will also solve the problem. We need a way for handling changes that require us to update the view. Sending notification to the view is kind of changing the the messages line that is displayed in our UI. The UI, just to see that it works as expected. Okay, this is the messages where so here we can just specify name of file, press load, and we can expect getting the file over the content over here. And if we have something over here, we can specify name of the file, press save, and that should be saved to that file. We can fix this lousy UI. For instance, let's change the text field, the messages. This is fine, but this one, let's make it bigger. So now it should look better. Yeah. Okay. We will stick with that for now. So we need to handle events. For instance, we need to handle the press of on save. So when pressing save, we want the content that is here, we love Java, to be saved to a.txt file or a.data file, whatever. So if we didn't have the view model in between, you could say, okay, should be very simple. The component, the UI, the view component, it will hold the reference to the model, but then there are problems, as I said before. Let's change the names over here. Let's change, instead of simple UI, we can call it simple view. And we can also add an interface. That interface allows us flexibility. And this interface will include methods that we want to allow calling on the object that represents the view. The object that represents the view is this one. Okay, so which method do we want? So before we talk about the method, we need to understand a bit more about the component in between. So instead of calling directly to the, let's see, we have on the model, we can call save data and load data. So instead of calling from the view directly to save data and load data on the model, we will call those methods on the view model. The view model indirectly, or not indirectly, will in response to that, we'll call load data or save data, depends on what method was invoked, on the model. And it will do it in a separate thread in order to solve the threading problem. So we need to define the interface for the view model. And that interface should include, at the minimum, the two methods we have over here. However, it won't be the same exact methods because we don't want these two methods to be synchronous methods so that if something bad happens, they throw exception. We don't want that. We want the implementation of these two methods to include code that invoke the save data or the load data on the model object. So yeah, I was I think I exaggerated thinking that I can complete it in 30 minutes. Okay, so let's understand a bit more about which object holds reference to which object and show that in our code. So I'm moving to my iPad. So we actually need to have a view model. This is the VM, and we have the model. And we have the view. Now, the view model must hold a reference to the model. It will call methods on the model in response for methods being invoked on the view model. The view will hold the reference to the view model. The view model will hold the reference to the model, but the view model will also hold a reference to the view so that if there is a need to notify the view about something, it will be possible. It would be possible. We have on the bottom of the view messages. We can show that error message there. We can put their error messages if something, if an exception is thrown. So, okay, so what we need now is to reflect that in our code. So we need to add methods to view model and to iView to allow setting these relationships. So back to the code, the iView model, a part of these two methods, it also should include a method for setting the model and for setting the view. This is about the iView model. The view, it should be possible to call a method for connecting the view with a specific view model. So we define set view model in iView. Now, if we get back to the simple view, we should implement this method. So it means that over here, there should be a variable iView model, sorry. And then over here in the implementation of this, we will put set this dot view model, assigned with view model, exactly. So we handled iView, we handled iView model. Now let's define the view model itself, the class that implements iView model. So it can be simple, let's call it simple view model. Implement view model, which means that we should implement these methods. And over here, we need to have a variable for holding the view. We also need to have a variable for holding the model. The view model holds references for these two components. Now, the implementation of save data, after all, this save data will be invoked from the view when the button is pressed. We have over here a button, not here. Okay, so we're out of time. So Well, my mistake. I thought I will make it. Would you be interested that we set another half an hour? Maybe we need more, an hour. This is my mistake. And then complete this meetup properly? Or do you want me to stop here and explain what is left to be implemented? What do you prefer? Please write down in the chat. You can also send me a direct message so no one will see what you write. What is your preference? Two options. One is that we stop here now and I explain what is left to be done. The other that we have we continue this meetup. We can do it next week, for instance, at the same time, and then we take an hour for completing the work. I apologize, my mistake. I thought that 30 minutes will be sufficient, but they were not. Okay, so we will, okay, so this is what we're going to do. We are going to stop now, and I can tell you that let me check the schedules. So we have two parts for this meetup, and then we continue properly. And I think I will prefer to allocate 1 hour, one more hour to be on the safe side that we indeed complete. Just a moment. Sorry for that. Just a moment. Okay, next week, the same time would be okay on your end? Okay, so we will do the following. Next week, the same time on Tuesday, but it would be an hour. Maybe it will take less, my mistake. So sorry for that. So next week on 13, okay? This is fine. If you're interested, just write down that this is okay with you. Okay, so as we said, we will continue from here next week at the same hour, 15 minutes past 1. Let's stop here and do it properly next week, and then we complete the code and explain everything. Okay, so goodbye for now, and I will update you formal with the details of the next part. Okay, bye-bye. So we now start the second part of the MVVM Architecture Meetup, a meetup that focus on the implementation of MVVM in Java, and the explanation is done together with coding, live coding. So last meeting, the first meeting, we already coded the model. So we started with the interface, and then a class that implements the interface. And we have already implemented those two methods. One method is capable of saving specific data string to a file, and the other method is capable of reading data from a specific file. So as explained last meeting, you should always start with coding those parts that other parts depend on. This is the best course of action. You start with the model, in this case, and only then you move forward to the view and the view model. So when you complete the model, you can code unit tests for verifying. We don't have time for that. But if we had, then that would be the case, and unit testing
would be coded. I would have coded a unit testing for testing these methods separately from the other part of the program. And only when I'm confident that the model is completed, it works okay, then I move forward and develop the view and then the view model. Now, the view is the component that is responsible for the UI, what we see on screen. The model is the component that is responsible for managing the data. It can be code model that works with a database, and usually this is the case. It can be model that works with data saved to files. It can even be a model that works with data we save in the memory. It can be a database that use memory, the RAM instead of the files, or it could be something we developed, something we need. It can even be a model that encapsulates the code that interacts with a web service from which we get the data, a web service that we use for saving data. So there are lots of possibilities you might encounter with when implementing the model. Now, the view can be simple code in Java that use swing classes for getting UI in a desktop application, but it can also be a view that use web technologies, kind of an hybrid application. It can also be a view that use other libraries, not Swing, just think about Android platform. And it can also be the view that is something that still wasn't developed. As you can see, we keep a separation between the interface, iModel, and the class. And the same, we have the iView interface and the class. Even the view model, the component that is in between, we have a separation between the interface and the class. So the moment we have those interfaces, iModel, iView model, we can always change the view, use another view, another class, another implementation, as long as that other class implements iView, that this is okay. So we also coded the simple view, a class that implements iView. iView for now has the method setViewModel. It is a method we can call on a view model in order to connect. Sorry, setViewModel is a method we can call on a view model on a view object, on the object that represents the view, in order to connect the view component with a specific view model. Other methods we might want to have is probably set message. So it would be possible to call set message on the view component in order to show a specific message on the bottom. Over here now we must implement set message. Okay. Now let's just see the view so we know what we're dealing with. So I will try to execute this code just so that we can recall what we have. So over here is the text field represented using a JText field object. Very simple. This is where we will show messages. And over here, I can specify a name of a file. And then when clicking save, whatever I entered over here, we can expect it to be saved to that specific file I specified its name. And we also have the load button. So when we specify a file name and click load, the content of that file is read, and we expect the content of that file to be displayed over here. So this is a very simple application. So it would be possible to finish it during the time we have. So in addition to that, we also have the component that is in between the view and the model. This is the view model. So again, we have a definition for the interface and then a class that implements that interface. So the interface specifies save data and load data. These two methods are actually the same methods you are already familiar with that we should define in the model. The iModel interface includes methods with a similar signature. It doesn't have to be the same name. I mean, you can use another name, but having the same name makes it simpler. So we have in iModel save data and load data, and in iViewModel we have save data and load data the same signature, but there is one difference. Here we have throws for a specific exception. Both methods have it. Here we don't. Because the idea is that calling save data will start an asynchronous execution of something of code using a separated thread just for the interaction with the model. And when the answer is returned back, and it might take some time, and we don't want to block the EDT thread. I want to explain that. When you click a button and a method is invoked in response, then that method is invoked during the execution of the event dispatching thread. It is very simple to handle button click. All you need to do, and we can do that, for instance, over here. You just need to specify the name of the button you want to handle. Let's say save BT, and then dot add action listener, and you should pass over a reference for an action listener object. So one option is to use an anonymous inner class, as I did over here, and then the code of this method will be executed whenever the save button is clicked. And it is important to pay attention to the fact that action performed is invoked during the execution of a very specific thread known as the event dispatching thread. This is the same thread that is also responsible for rendering the UI. It is the same plus more. It's very similar in .NET, Android, and many other platforms. When there is a method that is invoked when a specific UI event happens, that method is invoked during the execution of a specific thread that is responsible for rendering the entire UI. And you don't want to block that thread. So that's why over here, instead of calling the method on the model, we call a method on the view model. And that method returns back immediately because it just starts something else asynchronously. And so let's show that. Every view should hold an iViewModel object, so it should be possible to call a method on the object that is actually the view model, the object in between the view and the model. And then we can call the method save data. And we can take the string that is currently inside the text field that its name is fileNameTF. This is the first argument. The second argument would be the text that is inside the text field on the bottom. So this is how I call the save data on the view model object. Now, if we check the save data over here, then we should actually call the save data on the model object, but we should do it in a separated thread. So it would be best having well, I don't know if you're familiar with that, but there is a class. Its name is executors in Java, and you can call that class and call the new fixed thread pool and get an executor service object. So we can do the following. We can just define a simple constructor. And over here, make sure that we have an executor service. Okay, we will need more classes, so I put star. So over here, we can do the following: service, assign with that. So, or we can choose another method, new single new fixed thread pool with 3 threads, for instance, let's say. So now we will have a pool of threads we can always use, and then over when calling save data, we can do the following. We can submit, call the submit method. Submit expect getting a reference for a runnable object. So I pass over a reference for a new object instantiated from an anonymous inner class that implements runnable. And then over here, I can call the model dot save data and pass over the same arguments. And now here, calling save data on the model, there is an exception that might be thrown if something goes wrong. So we can surround it with try and catch. And if something goes wrong, then handling the exception would be actually calling the set method on the view object and passing over, let's say, we can just pass over the get message. So this is an error message. Maybe we can concatenate it with the word error. Okay. And we should do the same with load data. The same. I mean, over here, we should simply call the submit, or we can also do execute, and we pass over a reference for a new object that is instantiated from an anonymous inner class that implements runnable. And over here, I asked to, let's say we want actually to call the same method, but here an exception might be thrown, and if exception is thrown, then handling that exception would be like that. So let's see, why do we still have error here? You see why? Okay, let's complete the method. Set view, set model. So in our case, it should be very simple. This dot view assigned with view. This dot model assigned with model. Now it looks fine. We still have error over here. Yeah. Now load data shouldn't return a string. It should be a void. So let's fix it. In iView model, load data, this is a mistake. It should be void because it shouldn't return the data. It should start an asynchronous operation through which the load data will be called, will be invoked on the model object, and there we have code that access files, read the data, and make sure to show that data in the message text field we have in our view. So over here, when we get the data, we should take it and display it. In this case, it is about displaying it on the bottom, the text field that is the message, because we're doing something very, very simple. Okay, let's see. I think that this is it. We still have time, but we need to execute, and maybe there are bugs, probably. Let's take a look one more time. So we have the view model, and well, this is gray. AI view model and simple view model. We implemented everything. We still didn't use it. Okay. Now let's get back to the view. So over here, we call save data when pressing the save BT, and when pressing load BT, then something similar happens. We expect having a call to the method load data. Let's see that we refer to, no, it's not file path TF. Oh yeah, it is file path TF, and this is file name TF. Okay, so we get the name of the file from calling file path TF dot get text, and then that string is passed over to load data that is invoked on the model, on the view model, sorry, on the view model object, and over here we start a new, not, we don't start a new thread, we use one of the threads that the pool of threads manage for us, and we use it for calling the load data on the model, and when we get a reply, the reply is displayed back in the text field on the bottom. Now, there is one more limitation. If you don't want to get a deadlock, then specifically when dealing with a swing, every interaction with the user interface must be done, must happen during the execution of the EDT thread, the thread that is responsible for rendering the entire UI. So that's why we can't just call set message as we did over here and as we did over here. This line. By the way, we can also show a success message. But now there is a problem because the call to set message that actually refer a JText field object and puts a specific text inside it of that text field. Now it is not done during the execution of the EDT thread. It is executed during another thread. So this is a problem. This is a problem. And the same over here. This is a problem, so this and this is a problem. So either we solve this problem in the definition of set message, or we add some code over here. So I say we solve this problem in the definition of set message, then it will be less code to add. So let's get back to set message. We still haven't implemented it. And what we can do is I think there is a method. Yeah, this is it, is event dispatch thread. This method actually checks whether the call to set message takes place during the execution of the EDT thread. And if this is the case, then fine, we don't have a problem. But if this isn't the case, then we will do the following. String utilities dot invoke later, and inside the implementation of runnable, over here, we call the message TF, that's it. And that's it. Invoke later when you call it, and you pass over a reference for a runnable object, it is guaranteed that this run method will be invoked during the execution of the EDT thread. And this is exactly what we wanted to achieve. So now it looks fine. Let's get back to the interface. We still didn't call set model set view. This is correct because we need to connect the view model on one end, it should be connected with the model. On the other end, it should be connected with the view. The view model object should hold the reference to the model and the reference to the view. So let's connect the components here. when you run this method run, no, not here, the main method, where it is, not this is, sorry. Here it is. So what we can do is doing the following. Over here, we can create the new simple view model. Of course, VM, let's call it. And we should also create the model. Of course, we should import. And we should also, and of course, should connect the view model with the model and the view, but okay, so here we create the view model, here we create the model. Now, the view model on the one hand should hold the reference to the model, and on the other hand, it should hold the reference to the view. So we can pass over this because in this, no, not this, because this is the reference to the object that is instantiated from the anonymous inner class. So we want the reference to the object instantiated from this class. So simple view dot this. Means that, yeah. Okay, my typo. Here, we should do the following. Yeah. So okay, we don't have start defining the iView model, iView interface. So we can add it. Okay, public void start. Okay, so we create a view. We create the view model, and we create the model, and then connecting the view model with the model and the view. That's it. So let's summarize. The view model component should hold the reference to the model and the reference to the view. The view model, sorry, again, the view model component should hold the reference to the view and to the model, and it also should hold the reference to the model. The view component should hold the reference to the view model, not to the model, because any interaction with the model from the view will be carried through the view model. This is the responsibility of the view model component that is also responsible for solving the threading problem I told you about. We don't want that during the event dispatching thread, suddenly the thread will be blocked because there is a call to a call to a database or accessing specific file. So that's why we have the separated threads that the view model is using for using the model. So that's it. Let's see if it works and fix what is needed. And then we shall summarize using a simple diagram. So, okay, so I want to save to specific file the message we love Java. Let's see if it works. Let's call it a.txt. Okay, I call save. I press save. I don't know what happened. I feel that there is an exception. save data because is null. Let's see what is the problem here. The view, we forgot to connect the view should hold the reference to the view model. We forgot to do it. View with the view model. So view dot set a view model VM. We forgot to do it. So let's execute again. So the file is a.txt. We love Java. Pressing save. Okay, saving data succeeded. What actually happened is that pressing the button over here invoked the method save data on the view model object. And inside that method, we have a call to the save data on the model object that is done asynchronously. And when a message, and if something wrong happens, I mean, if there is a problem, then exception is thrown and the message that will be displayed on our view will be the error text with the message. But if everything works fine, then we expect getting saving data succeeded displayed on screen on that text field we have on the bottom. Now, let's see if loading data works. I want to load the data that was saved to a.txt. So I will press load. And as you can see, it works fine. What happened is the following. Pressing the load button, indirectly invoked the load data method on the view model object. And that method, load data, that was defined in our view model object, indirectly calls load data on the model that we have already developed last meeting. And as you can see, this happens in a separated thread. It doesn't happen during the execution of the EDT thread. We don't want to block the EDT thread. And if everything works fine, then the content of that file is returned back, and we ask to show it on the bottom, the message text field. If something wrong happens, then an exception is thrown, and the message on the bottom will be error and some message. We can see that if I try to load data from a file that doesn't exist, so a file not found exception should be thrown. As you can see, this is what I get. Okay, now in order to summarize what we did, of course you will get the source code. In order to summarize, I want to do a small diagram. So I will connect my iPad. Let's hope it works fine. Hope, not my typo. Okay. Do you see my iPad? I still need to see the code itself. How can I do it? You think how can I do it? Okay, so before a minute before, did you see my iPad? Just write in the chat if you saw it or not. It succeeded, the connection? Did you see my iPad when I tried to connect? No, you didn't see. Okay, so I won't use my iPad. I will use what Zoom has to offer. Okay, so let's do the following. I need some space over here on the right. Okay, so let's just summarize. We started with developing the model. So the model in our case is an object that is instantiated from a class that implements iModel. So the iModel is the interface, and then there is the class that implements that interface, and we can always take this class and use another class as long as it implements iModel. So we have the model. Let me create a small. Okay, so this is the model. Then we developed the view. But first we started with the interface, iView, and then we implemented that interface. And there are a few things to add. For instance, we should add code for handling closing the window. So the application will be closed. So we can do the following. That will be enough. So now when we execute the code and we click over here, we expect, yeah, the process finished. So we defined the view. And the last component is the view model, the one in between. Let's call it VM in short. So VM, the view model, holds a reference to the model. Calling methods on the model object directly is done only from code that belongs to methods that are invoked on the view model. The view doesn't interact directly with the model. The view interacts with the view model. The view includes code that calls methods on the view model object. The view model object is the only one that calls methods on the model because that those invocations of methods on the model object, they are carried in a separated thread. Now, the view model also holds a reference to the view. So it would be possible when something happens and we want to show a message on the view to show a message or to show some data on a specific text field. It doesn't have to be limited to a simple text field on the bottom. It can be more sophisticated, more text fields. The view model has the ability to inject text or another data inside those other text fields. Now, the view holds reference just to the view model. It doesn't hold the reference to the model because it doesn't call method directly on the model. It calls method only on the view model, and the view model call the relevant method on the model. And if it succeeds, then the view model call a method on the view to show the result or to show the error message if it doesn't succeed. Now, this is the basic implementation of the MVVM. If you search Microsoft MVVM, it all starts from this diagram. Now, Microsoft came up with this design pattern when they developed the WPF framework for developing UI, and after that, Silverlight, which is a kind of smaller version of WPF, and there we have something a bit different because we have XAML and some of the code is auto-generated for us. But if you try to implement MVVM view model in Java or in any other programming language, then you can expect getting something similar to what we did. So the view model is the one that holds the reference to the model, not the view. The view can call methods on the view model, and then the model call a method on the model. And we don't actually need the send notification back from the model to the view model, but we can do that. It all depends on what exactly happens. In our simple application, we don't need it because the call to the method on the model is done in a separated thread. And when it ends, either it succeeds or not, then the view model calls the set message on the view. Okay. Now back to the code. Questions you have, please don't hesitate. Okay, I should have tried draw that or that. I usually use the iPad. I don't know what happened there, that it didn't work. Do you have any questions so far? Okay, so few things. During the coding, I was using anonymous inner classes, and I know that some are not familiar with this topic. So if you're not familiar with this topic, then I can recommend you to check out the course I developed dedicated for anonymous inner classes and nested classes. Just go to the website, lifemichael.com. It can be the Hebrew version, the English version, it doesn't important. And then you can find under, okay, let's go back to English because we're talking English. Under training, you can find courses in social development, and here you can find lots of information about various courses. And there are courses that were developed on the Udemy platform. So if you click this link, you can find courses on Udemy, and those courses also include courses about various topics in Java. And here you have inner classes. You see inner classes in Java, so you can just click this link, and that will be a good catching up with this topic that I believe that not everyone is well familiar with. Another thing, if you check the courses, there is the professional section, and there are links to other courses in Hebrew. And I've just recently completed adding subtitles so I can share the first topics for free. So if you access this course, for instance, you can find the first topics for free. It can also be a good way for catching up. And one more thing, I don't know if you're familiar with, but I've started summarizing everything that is new in Java, Python, and JavaScript, and I have newsletters. Well, I don't have those links, but if you search LinkedIn, Java monthly review, and then here it is, newsletter. I've started every month. I take all the highlights in Java and just summarize them together. And the same with Python and JavaScript. Just search LinkedIn space Python monthly review or JavaScript monthly review, and you will get to the link to join that newsletter, monthly newsletter. That's all. Okay. Questions? Any question you have? Please don't hesitate. Otherwise, this is it. And the code, of course, I will arrange it for you. Okay, that's it. Okay, thank you for your time. I hope you learn something. You can tag this, in my opinion, this pattern. Some refer it as an architecture pattern, some refer it as a design pattern. It is a pattern you can also use when coding server-side microservices. Even in that domain, there are cases where you need that separation between a model, a view model, and a tiny view, not a view with a UI kind of swing-based UI, but something else. So it is also a domain where it might be relevant to implement a variation of the MVVM. Okay, then, so goodbye and thank you for joining, and bye-bye.